Okay, so this is a new chapter. Now we're going to start talking about more than one random variables. And this particular chapter is, I think, chapter 5 of the textbook, I believe. And it deals with pairs of random variables. And why do we need to deal with more than one random variables? In particular, we're going to start with two random variables. So just to give you a small example, so let's say if there's a robot that's somewhere in a two-dimensional space. So there's an x coordinate of the robot and there's a y coordinate of the robot, right? And the position, if I say that the position of the robot is random, that means there are two things that are random. The x coordinate which is random and there's a y coordinate which is random, and we may not be able to, or it may not it would not suffice to characterize the randomness in the x coordinate and the y coordinate independently of each other, right? So there may be some dependencies between what the x coordinate is and what the y coordinate is, and we need to somehow capture that dependency. To give you another example, which may make more sense, is that if I say that there's a random variable x, which represents the average, or which represents the age of a person in a certain population, and there's a random variable y, which represents the number of cigarettes that a person smokes, okay, a day, right? And both of these things are random, right? Both of these things are random, but we would need some sort of joint characterization of these two random variables, because we know that there's a dependency between the number of cigarettes a person smokes in a day with the lifespan of that person, right? So there's a dependency between a statistical dependency between the two, and we need to somehow capture that statistical dependency, and that is done through something called joint PDFs, joint PMFs, or joint CDFs. Yet another example that I can give you is, okay, if there's a random variable x that represents the final aggregate that a student gets at the end of the semester, and that's a random variable. And there's another random variable y, which is the average amount of time, let's say in hours, that the student spends on that particular course in a week. And both of these things are random, and we know that there's a linkage between the two, right? So whereas I would expect that the probability that people score between 80 and 100 is quite high, I would also expect that the probability that somebody not spending any time on the course is high as well. But I will not expect both of them to be high simultaneously. Okay? So the probability of the intersection may actually be small, right? So we need to therefore define functions or define characterizations which can find the relationship between two random variables. And one of the ways to do that is through these something called joint CDFs, joint PDFs, and joint PMFs. Okay, and that's actually something which completely characterizes the dependency between random variables. Okay, so we're going to start this off with a description or a definition of something called joint PDFs, joint CDFs in particular. So what are joint CDFs, by the way? Salman, what are joint CDFs, or what are CDF?
फिर ये रेंज निकालने के लिए प्रोबेबिलिटी की
हाँ,
यूज
लेकिन
होती है फिर
CDF is an acronym for what?
क्यूमुलेटिव डिस्ट्रीब्यूशन फंक्शन
Cumulative distribution function. So we've done a cumulative distribution function for a single random variable. Now we're going to
हाँ
define a
जी
cumulative distribution function for two random variables. Okay. I also want to point out here that this chapter extends the previous chapters by a small step, in the sense that previously we were talking about one random variable. This chapter is going to talk about two random variables. And the very next chapter, which is chapter 6, now it would then extend it to multiple random variables, which could possibly be more than two. Take us with baby steps at a time. So we're focusing right now at a maximum of two random variables, characterization of two random variables. Okay. So the joint CDF for two random variables is defined for random variable x and y is actually a two-dimension function, right? Where the arguments for that function are small x and small y. And the definition is that this function evaluated at small x and small y is actually the probability that the random variable capital X is less than equal to small x, and the random variable capital Y is less than equal to small y, right? So this is the definition of a joint cumulative distribution function evaluated for two random variables, capital X and the random variable capital Y. Okay? So and when I say comma, of course, that means this is an intersection of two events, right? So everything goes back to events, right? So this is a probability of the intersection of two events, those events being that capital X is less than equal to small x and capital Y is less than equal to small y. Now, given this definition, we can define some properties or describe some properties. So the first property is, so let me ask you, what is the CDF evaluated at minus infinity and minus infinity? Kyun Isha, what is the CDF evaluated at minus infinity and minus infinity? Remember, this is a two-dimensional function now.
Sir, at individually at in minus infinity, we know that it's 0.
Yeah,
So at minus infinity and minus infinity would also be 0.
would also be 0. So Khalid, you have the right answer. If you could, if you're using the chat box, just make sure you send a message to everyone, not to me privately, okay? So that everybody can benefit, right? So this is indeed 0, right? And actually, if I just define it at minus infinity and any y, and this defined as any small x and at minus infinity, this is also going to turn out to be 0, right? Because remember, this is the probability of intersection of two events. And the event that capital X is less than equal to minus infinity is actually the null set or the null event. Okay? And an intersection of that with anything is going to be null, right? So therefore the probability is going to be 0, right? So this is the first property of CDFs or joint CDFs. Similarly, the CDF evaluated at plus infinity and plus infinity, this is equal to 1, right? That should be clear enough. I mean, the probability that the random variable capital X is less than infinity and random variable capital Y is less than infinity, both of them simultaneously, is the universal set. I mean, they're of course guaranteed to be less than infinity, both of them. Okay. The third property is that since this is a probability, the function is always bounded between 0 and 1, right? So it's always bounded between 0 and 1. Okay. Now here's which is something which is maybe slightly different, right? What can I say about this thing here? X and infinity. What is this equal to? The CDF evaluated at capital X equals small x and y equals plus infinity. G Shoaib?
सर ये दोनों का इंटरसेक्शन होगा which will be CDF evaluated at x.
Good, right? So this is, if I go back to the definition is this is the probability that capital X is less than equal to small x and capital Y is less than equal to infinity. And I see that the second event, capital Y is less than equal to infinity, is actually the universal event. And an intersection of anything with a universal event is that thing itself. So therefore, this is just simply equal to the probability that capital X is less than equal to small x. And this is the CDF of X evaluated at small x. Similarly, I can conclude that fxy evaluated at plus infinity and small y is by extension is going to be equal to Kyunji Khalid. So Khalid, can you hear me? Okay, anybody else? What is this going to be equal to? G Mohsen?
Sir, FY.
Fy. All right. ठीक है? अच्छा. So these are some of the definitions of CDFs, joint CDFs, properties of joint CDFs. Okay? Let's talk about joint PDFs now, or joint probability density functions. And I'm just going to give you the definition here. The joint PDF, once again, is a two-dimensional function for two random variables. And the definition is that this is limit epsilon x going to 0 and epsilon y going to 0. The probability that x is less than equal to capital X is less than x plus epsilon x, intersection with small y is less than equal to small y is less than small y plus epsilon y divided by epsilon x times epsilon y, right? So do you see a connection here with the normal PDF that we defined earlier, right? So this is just an extension of the PDF that we defined for a single random variable. Okay. Now, if somebody could try to explain this in words, so, and where I can help you here in the sense that if I go back to a single random variable, we said that the PDF of the random variable capital X evaluated at small x is the probability that that random variable lies in an infinitesimally small region centered around x divided by the length of that length. Okay, divide by that region. Okay, so that was a PDF for a single random variable. How would you extend that definition or that verbal definition to this case here, given that you have this mathematical description available already? Ji, Isha, please go ahead.
Sir, we will have partial derivatives with respect to x and y.
नहीं, मैं चाह रहा हूँ कि आप जो है अगर इसको you were to explain this in words, what is this really equal to, or what is this really? I mean, Ji, Shoaib.
The PDF at x comma y is the probability of the intersection of the random variables x and y with the random variable x lying in an infinitesimally small interval around x1 and the random variable lying in infinitesimally small interval around y, normalized by the length of the interval.
Okay, so remember, it's not about. I think you mentioned this anyway in your description. It's not about them lying separately. कि x यहाँ पे पड़ा और y यहाँ पे पड़ा. It's just about that intersection. The probability of the random variables capital X and the random variable capital Y lying in an infinitesimally small region centered around xy. Okay, divided by the area of that region. Okay, so I mean, पहले length था in a single random variable case. Now you've extended that to the area of that region. Okay, so this is, if I were to explain this in words, this is the probability of x, y lying in an infinitesimally small. And actually, this region is a rectangular region. Which is around small x, small y, normalized by the area of that region. Right, and this then leads to the theorem that actually Isha mentioned as well. And there is a formal proof for this theorem that's given in the textbook. I think this is theorem 5.1 in the textbook. And we just says that the CDF, the PDF is actually equal to the partial derivative with respect to x and with respect to y of what? Of the joint CDF. right? So the joint PDF is the partial derivative with respect to x and the partial derivative with respect to y of what? Of the CDF. Okay? So just an extension of concepts that we've done already. So we're skipping the proof here, right? And therefore, if this is true, how can I relate the CDF back to the PDF? I mean, this is the expression that you see here is a relationship of the PDF with the CDF. If I want to invert this relationship,
Sir, double integral with respect to x and y.
right? So this is fxy. The CDF is equal to integral from where to where? This is minus infinity to x, and this is minus infinity to y, fxy, and then I use different variables here, uv, and this is dv du, right? So this is the relationship between the CDFs and joint CDFs and the joint PDFs, and the proof I'm going to skip here. So that's there in the textbook. Okay, so here are some properties of the joint PDFs now. And once again, we are not going to do formal proofs for this. This is pretty straightforward. The first thing is that the joint PDFs are always non-negative. Okay, they're always greater than or equal to 0. And this comes about because of the fact that this joint CDFs in one variable are monotones. Okay, monotonically non-decreasing. Okay. Similarly, another property here is that if I integrate from minus infinity to plus infinity, so in other words, if I find the volume under the curve, right? So remember, or volume under the surface, right? So the joint PDF actually is now a surface. Why is it a surface? Because it's a two-dimensional function. This is a function of x and this is a function of y. And in the third dimension is the height, which is the function is defined in the third dimension. Okay? And if I find the volume under this surface, that volume is always going to be equal to what? G. Mohsen?
1.
1. Right? Why is this equal to 1, by the way? G. Mohsen, why is this going to be equal to 1?
Sir, I can't explain it.
See, I mean, so you need to know. छोटी छोटी चीज़ होती हैं जो हम वो याद कर लेते हैं, लेकिन फिर then we forget कि यार ये why did this come about? जी गाजी?
Sir, PDF.
सर हम CDF से देख सकते हैं कि
Yes. So you
ऊपर वाले एक्सप्रेशन में डाल दें infinity.
Exactly. So you just plug in यहाँ पे infinity डाल दें और यहाँ पे infinity डाल दें. Right? So that means this is infinity and this is infinity. So the CDF evaluated at plus infinity and plus infinity that we've defined up above. Okay. That's an intersection of a universal set, and the probability of a universal set is 1. Okay. That's how this comes about. Okay. That's one of the reasons for this. Okay. So I'll leave this off as a note anyway in the notes for you to think about. Acha, here's the one important thing, which is what is fx of x? Fx of x, remember in the properties of the CDF, we define that to be, we said that this is going to be equal to fxy evaluated at x, and y, small y was plus infinity. Okay? So if I use this definition here, to get this definition here, so this is what? This is integral from minus infinity to x, and this integral is from minus infinity to plus infinity. This is fxy, and this is u v dv times du. Okay? That's a simple substitution in the definitions that we know of, right? If I differentiate both sides with respect to x, what do I get?
PDF of x.
So on the left-hand side, you're going to get PDF of x, right? So this is going to be the PDF of x. What about the right-hand side? What about the right-hand side? G Shoaib?
PDF of y at evaluated infinity, which will be equal to 1, multiplied by CDF of x evaluated at x.
So not really, Shoaib, क्योंकि देखें ये this is being integrated with respect to x.
जी सर.
ठीक है, so एक integral आ जाएगा जब integrate हो गया, and then you're differentiating it again with respect to x. So this integral and that derivative is going to cancel out. So, so Leibniz rule है या I forget the name of that rule, right?
So this will be so f of x comma f of x y
Yeah.
integral होगा from x to minus infinity. That's it.
Good, right? So it's not x from minus infinity. This is actually going to be minus infinity to infinity. So this
Oh,
is
yes.
fxy, and यहाँ पे x आ गया, and this is being integrated over y. Right? This just comes about by just differentiating the right-hand side. Okay? Shoaib, is that clear? What about everybody
Yes,
else?
sir.
I mean, there's another way you can get to this, by the way. I mean, not necessarily through differentiating. I mean, you can just compare something with something. I know that fx of x is equal to what? Fx of x is minus infinity to x, fx of x, और u कर दें यहाँ पे, times du. All right. So that should give you a clue of why this comes about. I mean, you just compare this expression with this expression here. And that's another way you can come up with the same conclusion. Okay? So I don't want to go there too much. But the point here at the end of the day, when you do that derivative, is that this holds, and this is extremely valuable. And similarly, if you want to get the PDF of y from the joint PDF, all you need to do is just integrate over. So यहाँ पे क्या आना चाहिए? So anybody else? जी Salman?
Yes, sir.
I mean, what should I do here? So if I were to now get a PDF of y and not a PDF of x.
सर वही है बस dy की जगह dx हो जाएगा.
Exactly, right? So you, instead of integrating with respect to y, you just integrate with respect to x. Okay? And these are extremely important identities, if you will, or relationships. And there's some correspondence with some law that we've done already, right? So this bears resemblance to some of the law that we've done already. Can somebody highlight कि क्या चीज हमने already की है जिसके साथ ये थोड़ी सी resemblance रखती है? जी गाजी?
Law of total probability.
Yes, how so? अब उसको
अगर आपके दो सेट्स इंटरसेक्ट कर रहे हैं तो आप एक के ऊपर सारे समेशन ले लेते हो ताकि आपको सिर्फ एक की रिस्पेक्ट प्रोबेबिलिटी।
Exactly. So एक की तरफ summation ले रहे हैं और over the entire universal set, right? So that's something that you're doing, right? So that's exactly what you're doing. So in order to find the PDF of X, right, what you do is that you take the joint probability and we say that this is, we marginalize, and this is called marginalization, marginalize over Y, right? So you consider each and every one of the possibilities of Y that it could take, right? And then you sum or integrate, in this case, because this is continuous, you integrate over all of the possible values that Y can take so that it goes out of the equation now, right? So when you integrate over Y, something that you're going to get is not going to be a function of Y anymore, right? And what it's going to be a function of is going to be a function of X only, right? And that function of X turns out to be the PDF, right? That's what this tells you. If you are given a joint PDF of two random variables, that is enough. That is enough for you to obtain the PDF, marginal PDF on X and marginal PDF on Y, right? So the joint PDF is more of a generalization, is a generalization, right? Because that tells you a lot more than what the marginal PDFs are going to tell you, okay? Because it's possible to go from the joint PDF to the marginal PDFs, and as we're going to see later, okay, it's not always possible to go from the marginal PDFs to the joint PDFs, okay? So joint PDF is a higher level of characterization. Okay? It provides more details about how the random variables are distributed or how the random variables are related to each other, right? Similarly, so this is marginalization over Y, and we say that this is marginalization over X. Okay, so this is extremely important, which we're going to use quite a bit, which is used very, very often. Okay, and finally, the final property here for joint PDFs is that if I were interested in finding the probability that the random variable X and Y belong to a certain region A, how should what will this be equal to? Ji Abdullah, what do you think?
Yes, sir.
So what do you think this probability should be equal to? I mean, if I'm given the joint PDF.
So if X and Y belongs to A,
Yeah, so what is the probability that the random variable X and Y belong to A? If you know the joint PDF.
sir, I'm thinking.
That's
Just
okay.
a minute.
That's okay. So Josefa?
So this A is basically an event over both X and Y.
So A is some region in the XY plane.
Oh, okay. And okay, so it belongs to that.
Yeah.
So basically,
So this is some region in the XY plane, which is deterministic. अगर मैं आपको कहूं कि जी एक single random variable था, एक single random variable है, and I ask you to find the probability that that single random variable lies in a certain interval.
so we integrate over the area A for both the integrals.
Yeah. So
for X and
except that now you have a double integral.
yes.
Right. So you only integrate in those parts of the XY plane which belong to that region A. Okay. And what do you integrate? You integrate the joint PDF. Right. And there's a rigorous proof for this. I'm not going to go through the rigorous proof. I'll skip that. Okay. But it's just a simple extension of what we did with the single PDF. Okay. If I were to compute the probability that a random variable lies in a certain interval, what I'll do is I'll integrate that probability density function over that interval. Okay. And this is exactly what we're going to do over here as well, except that integration is going to be in a two-dimensional space, right? the region over which you're going to be integrating is 2-dimensional, and the third dimension is the height. Okay, so this is also extremely important. Okay, all right. All right, so let me do some examples here. Okay. So these are some examples. I mean, so which for all of these concepts about joint PDFs and getting the marginal PDFs and so on and so forth, right? So this is example 1. And this has to do with that robot thing that I was mentioning, right? So let's consider 2 random variables. 2 random variables, X and Y, capital X and capital Y, are jointly uniform.
सर आपकी स्क्रीन अनशेयर हो गई है क्या?
Oops. Okay. See it now? All right. Right, there you go. So let me say this again, right? So there are 2 random variables, X and Y, and those random variables, X and Y, are jointly uniform over a circle of radius 1, right? So this could basically apply to a robot, for example, that could be in a 2-dimensional space. And in that 2-dimensional space, we expect that the robot could be anywhere or uniformly anywhere inside a circular region of radius 1, right? So this is the x-axis, this is the y-axis, and I know that the robot would be anywhere, cannot go outside. So first of all, cannot go outside of this unit circle. Okay, this could be 1 meter, this could be 1 kilometer. I mean, the units are not important. It's inside this, and the important point is it can be uniformly inside anywhere in this unit circle. Okay, now the capital X is a random variable which represents the X coordinate of the robot. Capital Y is a random variable which represents the Y coordinate of the robot. Okay, and if it's uniformly distributed anywhere inside this unit circle, that means is that the joint PDF of X and Y, the 2 random variables X and Y, is going to be equal to some constant as long as for any values of X and Y which satisfy X squared plus Y squared is less than or equal to 1, right? So it's going to be a constant for all values of X and Y residing in this unit circle, and is going to be 0 otherwise. ठीक है, तो अगर आप इसकी सरफेस को अगर विजुलाइज कर रहे होते तो किस तरह की सरफेस दिखती है? I mean, what would it look like? I mean, I've given you this expression here, right? So fxy equals c, x for all values of x squared plus y squared is less than or equal to 1 and is 0 otherwise. So what would it look like? I mean, if you were to visualize this in 3 dimensions now.
Sir, a disk?
A disk? Well, in 3 dimensions, the disk is 2 dimensional. Ji Mohsin?
Sir, cylinder.
Cylinder. Ji Abdullah?
सर स्फेयर नहीं हो सकता?
Sphere नहीं होगा because sphere can take on negative values and the PDF is never negative. सबसे पहली बात तो ये.
ठीक है सर.
Right? So the height can never be negative. So always has to stay above the XY plane, right? So the Z must always be positive. So there's a dimension that's coming out of the page here, okay? And it stays, the height stays constant for all values between x squared plus y squared less than or equal to 1. So that's nothing but a cylinder. Okay, that's a cylinder, right? What would this C be equal to? How do I find the C? So पहली बात यह है कि what is C? G Nazish, how do I find C?
इसको integrate करेंगे on this area
Yeah.
and equate it to 1.
Right. So x squared plus y squared is less than or equal to 1. C dx dy. I know that this must be equal to 1. Right. And why am I integrating only over x squared plus y squared less than or equal to 1? Because I know that this is 0 outside of this interval or this region. G Mohsen? You have a question?
सर इसका जिस तरह हम यूनिफॉर्म डिस्ट्रीब्यूशन के साथ उसको नॉर्मलाइज करते थे विद द लेंथ ऑफ द इंटरवल, इसके साथ हम 1 नॉर्मलाइज्ड बाय द एरिया ऑफ दिस इंटरवल कर सकते हैं.
Yeah, exactly. So that's exactly what's going to happen. Lekin I would want to go through that calculus route a bit. Okay? And that should be pretty straightforward anyway, right? So that's exactly what you're doing. So what is the integral on the left-hand side? That's what I'm interested in. So this is C. Oops. This is C integral x squared plus y squared is less than or equal to 1 dx dy. So this is actually, I just want to test you. What is this equal to? Kyun Isha? What is this double integral equal to?
Sir, नहीं याद.
Maz? G Ali?
Pi के equivalent होता है.
This is equal to pi. I mean, this is the area of a circle, pi r squared. This is going to come up again and again, this multivariable calculus. So it's important for you to perhaps revise those concepts. Okay, so multivariable calculus के, right? खासतौर पे हम जब टू डायमेंशनल में ज़्यादा अगर रहते हैं तो उसमें पोलर टू रेक्टेंगुलर और इस तरह की चीज़ें शायद हमें इस्तेमाल करनी पड़े, right? So the C pi I know that is going to be equal to 1, and this leads me to the conclusion that the constant C is actually equal to 1 upon pi. And as this is exactly what Mohsen mentioned, right? So जहाँ पे uniform distribution in a single dimension was equal to a height which was 1 upon the length of the interval. In this case, it's going to be 1 upon the area of the interval. So that would ensure that the volume is equal to 1. Okay? Okay, so that was the easy part, right? What about the marginal PDFs? So determine fx of x and fy of y. So first off, I mean, what do you expect? The marginal PDFs, are they going to be uniform random variables themselves or something else? Let's just take a guess here and then see what answer do we get.
Sir, could you repeat the question?
So what do you expect if I ask you to compute what the marginal PDFs are? Right, marginal PDF से मुराद क्या है? I mean, what is the PDF on the random variable x and what is the PDF on the random variable y? Right? Would you expect the PDF on the random variable capital X to be a uniform PDF? क्या ख्याल है? Any guesses? Any wild guesses? No guesses? कोई guess ले लें.
Sir, yes.
All right. So Isha says yes. Mohsen?
Yes, sir.
Yes. Okay. Anybody says no?
Sir, me.
Yes. Why, Shoaib?
Square है, अगर नहीं होता तो we might be able to get that.
Yeah. Okay. Square है, sorry, फिर से कहिए, square है या circle है?
अगर ये स्क्वायर नहीं होता तो फिर ये स्क्वायर होता, वो सॉरी मैं बोल रहा हूँ, अगर ये स्क्वायर वाई स्क्वायर नहीं होता ना तो फिर ये शेप स्क्वायर होता एंड फिर आ जाती है हमारे पास यूनिफॉर्म.
Okay, good. Right. So have you dealt with this joint PDFs before? I mean, if you give me an idea of the undergraduate probability course that you did, उसमें क्या हुआ था? Did you deal with multivariable random variables?
यस, हम जॉइंट पीडीएफ करिए 200 में. ये वाली एग्जांपल नहीं करी, but करिए.
Okay. Right. So okay. So by the way, next semester one of our EE colleagues is going to be teaching probability. All right. So the question is, what is fx of x? Now, how do I go about finding this out, right? So if you recall, I mean, this is obtained by a marginalization process, right? So this is integral from minus infinity to plus infinity of what? Of the PDF, joint PDF, x, y with respect to y, right? How do I value this integral now? And how do I value this integral? Anybody who can help me here? So इंटीग्रल निकालना है, कैसा निकालूं? जी माज.
सर हम इंटीग्रेट करेंगे इसको, मतलब क्योंकि हमें पता है कि x² + y² <= 1 रीजन है, तो हम उसको इक्वालिटी से वी कैन फाइंड y. तो y की दो वैल्यूज आएंगी बेस्ड ऑन x है ना, तो
या
अब तो y टेंड्स टू, मतलब y की लिमिट बनेगी -√1 - x² टू +√1 - x².
Right, excellent. Right, so here's the thing. So any x that I take, right? So this is x and this is y. Any x that I take, first off, x can only be between -1 and +1, right? That's something it should be clear, right? Any x that I take, right? So y is only going to be between what and what? So this, if this is x, this is √1 minus x², and this point, so this is this y, and this is minus √1 minus x², right? So any x that I give you, this joint PDF is going to be equal to a non-zero quantity as long as y stays between this value and this value. ठीक है, that's जो कि नजर नहीं आए. It's as long as it stays between -√1 minus x² and +√1 minus x², right? As soon as y goes out of this interval, the joint PDF becomes equal to 0. Okay? So, and within this interval, the joint PDF is equal to a constant, which is equal to 1 upon pi. So this is integral from -√1 minus x² to +1 minus √x². And you integrate over what? 1 upon pi. So that's this thing here times dy, and this turns out to be equal to 2 upon pi times √1 minus x². So this is the PDF. And if I can summarize here, so fx of x is equal to 2 upon pi 1 minus x². Is that all, or कुछ और करने की जरूरत है? I mean, this is not a complete description, by the way. There's something missing. Gmaz?
सर वो x के ऊपर लिमिट आएगी ना कि -1 to 1 ही होगा x.
Yeah, so this is -1 is less than x is less than 1. चलो equality कर लें because continuous है, right? So this is your conclusion. This is the PDF of X. What about the PDF of Y, by the way? PDF Y निकालने को कहूँ तो क्या करें? I mean, you can, if you wish, go about this process all over again, but you don't really need to. I mean, little more thought reveals that there's an inherent symmetry in the problem, and because of which, f y of y is going to take on exactly the same form. 2 upon pi root 1 minus y squared, and this is minus 1 is less than y is less than equal to 1. Okay. Now, is this uniform? Oops. Kyun, Isha? Is this a uniform distribution?
No, sir, it's not.
It's not a uniform distribution. I mean, what kind of a distribution is it? So my pen is stuck. Just give me a minute. All right, there you go. So what kind of a PDF would you expect? I mean, sketch, Mohsin, किस तरह का होगा?
So it takes on the value of 2 by pi when y is 0, or then it decreases to 0.
It decreases to 0. It decreases sort of squared and is like this as well, and it's symmetric, right? So from, and where does it go back to 0? This goes to 0 when x is equal to either plus 1 or minus 1. So can stay 0 then, right? So what this is telling you is that the x coordinate is more likely, what is it telling you? Is more likely to be around 0 or is it more likely to be around 1? क्या ख्याल है? I mean, so if you just look at this PDF and I ask you, is the x coordinate of the robot more likely to be around the origin or 0, or is it more likely to be around plus 1 or minus? Around the origin, right? Right? What is the intuitive reasoning behind that? क्या ख्याल है? And the same goes for y, by the way, as well. If y of y is also more likely to be around 1, and they're similarly distributed, so plus 1 and minus 1. And you can look at the circle here again to try to find the intuitive reasoning. So who can explain to me what the intuitive reason for the x coordinate to be more likely to be around the origin is compared to 1?
Sir, the maximum of the PDF.
But the PDF stays constant. PDF, the joint PDF is uniform. Okay, so अब you're saying कि जो f(x) of x की maximum PDF 1 पे आ रही है, लेकिन मैं ये पूछ रहा हूँ क्यों आ रही है maximum 1 पे? क्या intuition है? So I just I recall one of my discussions with my advisor when I was doing my PhD. So I had derived some results and I said कि जी ये चीज़ ये इस तरह होनी चाहिए. मैंने said कि कोई 3 चीज़ों के बजाय एक चीज़ लगाएं तो काफ़ी होगी. And the advisor asked me कि why do you think that is? And I told him कि वो equation देखें, वो equation देखें, इससे ये आ जाता है, इससे ये आ जाता है, इससे ये आता है, and so on and so forth. And then he rebuked me for that. He said, I am not talking about equations. Give me an intuitive answer. You should be able to explain it in simple words. Why do you think one of those things was enough instead of 3? Similarly here, I mean, one of the answers you could come up with is कि when I evaluate the PDF maxima जो है वो 1 पे आता है. That means एक कोई मैंने सारी derive कर ली है and derivation मुझे बता रही है कि it's very, very likely to be around 1. but what's the intuition behind it? I mean, what is the intuitive reasoning behind it? शोएब आपने हाथ खड़ा किया था.
जी सर, मुझे ये लग रहा है कि फॉर इंस्टेंस अगर उसे प्लस एक्स से माइनस एक्स जाना होगा तो इट विल क्रॉस जीरो, एंड उसे माइनस एक्स से प्लस एक्स जाना होगा सो इट विल हैव टू क्रॉस जीरो. So in any case, it will have to cross zero. That's why हमारे पास probability of finding it with respect to the x position will be much greater at zero.
Okay. नाजिश आपने भी हाथ खड़ा किया था.
सर जब x equals 0 है तो उसके पास y है from -1 to 1 जाने के लिए. For x greater than or less than 0 उसके पास y कम हो जाता है to move in.
Good. Excellent. So it's about the areas. Excellent. Right? So here's a very, very intuitive answer to this. And the intuitive answer is, okay, if I'm talking about a circle, right? Or यहाँ पे x equals 0 is somewhere, is exactly over here. And if I ask you to find the probability that x is between minus epsilon and plus epsilon, where minus epsilon and plus epsilon are very, very small, right? So what you would do is, okay, you see, you'd pick up this slice, right? And you pick up this slice, and the probability that the random variable capital X is between minus epsilon plus epsilon is going to be whenever the robot lies in this region. जब भी robot इस region में है, you would say that the x coordinate is going to be between minus epsilon and plus epsilon, right? Or which is around 0, right? But if I ask you what is the probability that it is between 1 and 1 minus epsilon, in that case, this is going to be the region. And the probability that the robot is going to be in this region is going to be much, much smaller than the probability that the robot is going to be in this big region here. Okay? And the underlying reason, of course, is because of the y coordinate. Okay, y coordinate जो है, when x is around 0, the y can take on a large range of values. And the robot can be anywhere from close to -1 to plus -1 as far as the y coordinate is concerned. But when x is close to +1, y can only be around +1, or y can only be around 0. Okay, just very, very slightly around 0. Okay, and that's the intuitive reason for that. Moaz?
जी सर. सर ये जो प्लॉट किया आपने पीडीएफ, तो इसका शेप थोड़ा डोम शेप नहीं होना चाहिए था, ये तो आपने
Sir,
रिप्लास
I
टाइप बना दिया.
was about to ask the same question कि ये
क्योंकि स्क्वायर रूट
इसकी सर्कल से ज्यादा मिलती भी नहीं होगी.
स्क्वायर रूट फैशन में आ गया ना नीचे, तो ये थोड़ा डोम शेप 1 2 क्रॉस करेगा, एक डोम टाइप बनेगी चीज.
हाँ, राइट. सो ओके, सो डोम से क्या मुराद है? इसी तरह आप पीडीएफ की बात करें.
जी सर, ये थोड़ा सा एक्सपोनेंशियल टाइप बना दिया आपने, मतलब एक स्क्वायर रूट का फैशन देखें तो ये नहीं बनता.
So the tangent would not be
सेमी
going to 0 but going to infinity.
So okay, so yeah, you're saying कि थोड़ा सा ऐसे होगा, थोड़ा सा सर्कुलर होगा.
These are totally inverted.
नहीं,
Like
ऊपर से
वो आपको apparently एक circle की तरह ही नजर आएगा between -1
Yeah, so
and
I
1.
mean, you get the point, right? So it decays. I mean, that's all I want to emphasize, right? It decays and goes to 0 at y equals 1. Okay? So it's like a circle region that I agree. Right? Okay. G Shoaib?
Sir, can you go a bit up? मतलब थोड़ा सा ऊपर scroll कर सकते हैं?
Tell me when to stop. So this is...
lag. ओके, ठीक है. ओके, सो अगर मेरे पास यहाँ पे एक्स स्क्वायर प्लस वाई स्क्वायर लेस देन इक्वल टू 1 नहीं होता, मेरे पास एक्स प्लस वाई लेस देन इक्वल टू 1 होता, स्टिल आई वुडंट हैव बीन एबल टू कंक्लूड कि मेरे पास जो एक्स और वाई की जो डिस्ट्रीब्यूशन आती है वो यूनिफॉर्म आती, इजंट इट?
या, ट्रू.
ठीक है.
एक्चुअली अगर आप जो है, if you want that to be a uniform, तो
स्क्वायर
हाँ, स्क्वायर होगा. Basically, absolute of x is less than 1 and absolute of y is less than 1. So there's no relationship between x and y. और constraint जो है, dependency नहीं है एक दूसरे के ऊपर. Independent constraints होंगे.
Yes, thank you.
ठीक है? You could also have a diagonal, by the way. I mean, you can play around with this quite a bit. Absolute of x plus absolute y is less than 1. That's another possibility.
Yes.
ठीक है, तो वो आई थिंक वो बन जाएगा, डायमंड बन जाएगा. ऑलराइट, so let me do another example. So the joint PDF that's given to you is 1 upon 2 pi e raised to power minus x squared plus y squared divided by 2. And as we'll see in our discussions, perhaps in the next class, this actually corresponds to a jointly Gaussian distribution, right? So, which is extremely important as well. But I mean, without really knowing what this PDF is, what the joint PDF is, we just want to apply the concepts that we've learned already, right? So given this PDF, what you're required to find is find the probability that x, y lie inside a unit circle. And you could take it back to, if you wish, back to the robot example, and you can say that the अब robot में x y जो coordinates हैं, well, those x y coordinates could be anywhere in a two-dimensional universe, right? So from minus infinity to plus infinity. However, it follows this. It follows this shape. Give me a minute. It follows this expression, right? And as we're going to see later, this expression is a sort of a Mexican hat, right? It's centered around x equals 0 and y equals 0, and then it exponentially decays from there. So it's the maximum on the origin, and then as it goes out radially, it decrease करना शुरू करता है, ठीक है? And this is a jointly Gaussian distribution which is used to model quite a number of things. Here you could say कि ये robot है जो कहीं भी हो सकता है, लेकिन is more likely to be around the origin, right? And then you say, what is the probability that your robot lies inside a unit circle? In other words, the x coordinate and the y coordinate reside inside the unit circle. Okay? If this is what you were required to do, how would you do it? So you want to find out the probability that x squared plus y squared is less than or equal to 1. This is what you want to find, right? The probability that x, y lie inside a unit circle is the same event as x squared plus y squared being less than or equal to 1. Okay, but that defines inside a unit circle, right? How do I find this then? How do I evaluate this? So this is integrated for where x squared plus y squared is less than or equal to 1. And I integrate what? I integrate this 1 upon 2 pi exponential minus x squared plus y squared upon 2 dx dy. क्या करें जी? How do I go about this integral? जी शोएब.
It's a long shot, but I'd still like to say it. If we convert it to polar coordinates,
Good.
तो मेरे पास जो मैंने थोड़ा सा करा अभी देख के, तो हमारे पास वो आ जाएगा, गॉसियन आ जाएगा.
Alright, so उस तक हाँ गॉसियन आ जाएगा, लेकिन वो बड़ा आसान हो जाएगा. It's not a long shot, Shoaib. You would convert to polar coordinates, and that's the easiest way to do it. Right? Polar coordinates, here remember, dx dy is equal to r dr d theta. Right? That's the first thing. And of course, x squared plus y squared is r squared. Right? And I just make the substitution. So the probability that x squared plus y squared is less than or equal to 1 is integral 1 upon 2 pi e raised to power minus r squared by 2 dxy becomes r dr d theta. What about the integrals? Where to where? Isha?
Sir, the 0 to 2 pi.
The angle goes from 0 to 2 pi. What about the radius?
0 to 1.
0 to 1. ठीक है. So इसको कैसे इंटीग्रेट करूं? And this is not as hard as it maybe looks.
Sir, we can simply integrate one with respect to d theta and the rest with respect to dr, and the product of
Yeah,
it.
so they're not mixed integral, right? So d theta and the kami niara, so there's 2 pi is going to cancel with 2 pi, right? So this is actually just equal to 0 to 1 r e raised to power minus r squared by 2 dr. And then here I notice this r is actually nothing but the derivative of r squared by 2, right? And that makes my life very, very easy, right? So therefore, this is just equal to e raised to power minus r squared by 2 integral, because of the minus sign, this becomes 0 to 1, right? So this is 1 minus e raised to power minus 1 by 2. There you go. Okay, so just a simple bit of multivariable calculus. And we do have time for another example. So if you really think about this, this is nothing but calculus. So here's example 3, fxy xy equals half e raised to power minus x minus y by 2 u of x times u of y. And you're required to find the probability that x is greater than y.
Sir, I had a question. Why did we switch the limits in the previous one?
Because of the minus sign. ये minus, ये देखिए ये minus था.
Oh, okay, okay.
Right, so I've just skipped a step here.
Okay.
ठीक है. Right, so how do I find the probability that x is greater than y? So this once again is multivariable calculus, right? So you have an xy plane, and the first thing is that the PDF is defined only for values of capital X and Y which are positive, right? So this is only defined over this first quadrant, right? And in this, you need to look at what the region corresponding to X is greater than Y is, right? So essentially, असल में हमने करना क्या पड़ेगा, right? So you would have to say, essentially, probability that X is greater than Y is actually equal to the integral over the region which corresponds to the condition that the constraint that X is greater than Y, small x is greater than small y, and then you integrate the PDF. E raised to power minus x minus y by 2 u of x u of y dx dy, right? So this is an integral you just need to find. How do I find this integral? क्यों सलार? जी माज
सर उसके मतलब दो तरीके हैं, या तो डायरेक्ट डबल इंटीग्रल लिख सकते हैं या फिर हम मार्जिनल वैल्यू फाइंड कर लें x का, फिर उसके ऊपर ये वाली कंस्ट्रेंट लगा के। मतलब अगर हम इन केस हम डबल इंटीग्रल लिखते हैं
तो मार्जिनल वाले से नहीं होगा माज.
अच्छा सॉरी
Okay, when you say what is the probability that capital X is greater than capital Y, so this is not really a condition on capital X only, and neither a condition on capital Y only. It has a condition which involves both of the random variables together. Okay, if this condition was what is the probability that capital X is greater than 2, then you could have done what you're saying. Okay, let's just find the PDF of X first, and then just integrate that PDF of X from 2 all the way up to infinity. But the condition you have here is an interlinked condition between X and Y. So you cannot work with the marginal PDFs, right? So what was the other option you're saying?
सर वो फिर अगर डबल इंटीग्रल लिखेंगे x की लिमिट्स होंगी y to infinity क्योंकि x is greater than y, and for y we will take 0 to infinity because
Right.
y u of y is.
Okay, good, excellent. Right, so this is x equals y line. Okay, this is x equals y, or x is greater than y, so this is where you need to integrate over, right? This is the region in which you integrate over. So this region corresponds to x is greater than y, right? So then I can see here this is going to be equal to integral. मैं करता हूँ कि I can take x from 0 to infinity and y from 0 to x, right? माज आप जो कहते थे वो आप कुछ और कहते कि y को 0 से infinity ले लें, and that also works, and x को y से infinity ले लें, that also works, and you're going to get the same result, right? I'm going to do this way, okay? I'm going to take x ranging from 0 to infinity and y from 0 to x, right? So once again, another multivariable calculation. So x यहाँ पे मैं लेना शुरू कर दूँ तो y मुझे यहाँ से यहाँ तक जाएगा सिर्फ, right? Right. So this is half e raised to power minus x minus y by 2 dx dy, right? This is half 0 to infinity e raised to power minus x minus y by 2 0 to x dx. So what I've done is I've integrated over y. So integrated over y, so this becomes 2, or there's a minus sign here as well, right? So this 2 cancels with 2, and this is integral from 0 to infinity. This is e raised to power minus x minus e raised to power minus 3 by 2x dx. And what would you get? This is e raised to power minus x 0 to infinity minus 2 by 3, and there's a plus sign, minus 3 by 2 and 0 to infinity. Okay, yeah. So this is 1 and minus 2 by 3. So this is x here. So this is 1 by 3. There you go. Right, so 1 by 3 is the answer. Right, all this takes is some calculus. Okay. So I'm going to stop here with the examples, and next time around we'll do conditional PDFs. Okay, so I deliberately did these examples even though I felt it's not really necessary. These are all basic multivariable calculus, but I realized this multivariable calculus might be quite rusty for many of you. So that's why I went through these examples anyway. Right? Any questions here?